Good morning, everyone. Today our group is going to explore the fascinating world of melanocyte and melanogenesis. We have an amazing team with us. Sara Pasquel, Fernanda Pavón, Domenica Basantes, Mateo Bolaños, Dani Guerrón, Itis Takuri, Karen Jaramillo, Elias Pillajo, Juan Pablo Yacelga, Roger Gomez, Jessica Ramirez, and Stefania Panch. We'll make sure it's engaging, so let's get started. Let's start with the introduction by Sara Pasquel.
Thank you, Karen. Melanocytes reside in the basal layer of the epidermis, where they form the melanoepidermal unit, a region of the melanocyte to 30 and 40 keratinocyte. The molecular structure presents tyrosinase relate proteins 1 and 2, melanosomal matrix proteins, and microphthalmia associated transcription factor.
I'm going to talk about melanocytes' characteristics and types. First, microscopically, they are oval or sponge-shaped, dendritic, and they are smaller than keratinocytes. The organelles to be produce the melanin are the melanosomes. They are present in the cytoplasm. About types of melanocytes, in the right, we can see continent melanocytes, and in the left, secretory melanocytes. First, secretory. The characteristic is that they have dendrites and be in the epidermis and air follicles. And the second continent don't have dendrites and be in the left meninges and the retina and dermis. Something interesting is that the own cells that produce melanin are the secretory cells after the embryonic stage.
The life cycle of melanocyte consists of lineage specialization of embryonic neural crest cells, melanoblasts, migration and proliferation of melanoblasts, differentiation of melanoblasts into melanocytes, maturation of melanocytes acquiring the dendritic morphology, and transport of mature melanosomes to keratinocytes and their eventual cell death.
The phenotypic diversity of pigmentation is not due to variation in the number of melanocytes, but to the size and number of melanosomes, the amount and type of melanin. The melanosomes of dark-skinned individuals are larger, more numerous, and elongated, resulting in an delayed degradation of granulocyte and consequently an increased invisible pigmentation.
Embryology. Melanocytes originate from neural crest cells. During their embryonic period, they migrate through the mesenchyme located in their respective size. This is because melanoblasts respond to various signals such as endothelium, stem cell factor, fibronectin, WE38, one from morphogenic protein 4, BMP4, transforming ground factor B, retinoic acid, and hepatocyte ground factor.
There are 4 stages in the development of melanosomes. Stage 1, premelanosomes are small round vesicles with amorphous matrix. Stage 2, melanosomes, they have a fibrillary matrix and tyrosine is present, but pigment synthesis has not been initiated. Stage 3, beginning of melanin production, the pigment is deposited on fibrillar proteins, and finally, stage 4, the melanosomes filled with pigment.
Well, I'm going to talk about melanogenesis. Melanogenesis is a process that involves stages such as melanocyte formation in the embryonic stage, melanin synthesis in the melanosomes, and its transport from the melanosomes to the keratinocytes. The skin has the melanoepidermal unit, which is responsible for the production and distribution of melanin. Melanogenesis can generate different types of pigmentary defects, hypo or hyperpigmentation, which can occur with or without alteration in the number of melanocytes. Melanin production is influenced by genetic and environmental factors, including UV radiation, which stimulate melanin production for the protected skin. Hormones like melanocyte stimulate hormone MSH also regulate melanocyte activity. Disruption in melanogenesis can lead to pigmentary disorders and affect the skin's response to the external factors.
Melanin has numerous properties that are beneficial to the body. For example, photoprotective and neutralization of free radicals. There are two types of melanin. One, eumelanin, which is an insoluble polymer and is characterized by its brownish black color and its photoprotective power. And two, phenolmelanin, which is a soluble red-yellow polymer formed by the conversion of cysteine, predominantly in individuals with light red hair, phototypes 1 and 2, in whose skin tumors are more common.
Now, in the synthesis. Melanin synthesis is initiated by tyrosinase on the amino acid tyrosine, which catalyzes the conversion of L-tyrosine to L-dopa and then to melanin. TRP1 plays a role in the activation and stabilization of tyrosinase, in addition to participating in the synthesis. It also helps to increase the eumelanin to phenolmelanin ratio.
Well, about the transport, when melanosomes melanize, they are then transferred to the keratinocyte where they are degraded, and finally the melanin is removed with the desquamation of the stratocorneum. Upon completion of melanin synthesis, melanosome moves from the perinuclear area to the melanocyte dendrites by proteins kinesin and dynein.
So continue talking about this transfer. It will end when the melanosomes bind to actin filaments through a complex formed by myosin BA, RAP27A, and melanophyllin. Upon reaching its final location, melanin becomes the main determinant of skin color. So in summary, we can say that the function of the melanocyte is to produce melanin, which has a photoprotective action against the harmful effects of the sun by dispersing and absorbing radiation. And talking about melanogenesis inside the melanocytes, what occurs is the formation of the melanosomes, the melanization of melanosomes, the transport, and the transfer.
Okay, now let's continue with keratinocytes. Within the keratinocyte occurs melanosome degradations and elimination of melanin with desquamations. As mentioned before, there are eumelanin with a photoprotective power and by being able to capture free radicals. And phenolanin can give birth to free radicals when irradiated by UV rays. Keratinocytes will be more or less protected from UV aggressions depending on whether they receive eumelanin photoprotective or photomelanin photoaggressive. Finally, some examples would be albinism, melanosation, defect of melanosome due to an alteration of tyrosines, and vitiligo acquired and progressive decrease in the number of melanocytes. Thank you for your attention. I hope everything is clear. If you have any question, please feel free to reach out to me. Thank you.